Hello students, this is Mr. Ezra. We've been spending a lot of time lately talking about how to factor and how to solve polynomial functions. Today we're going to reverse the process a little bit and talk about how to write out the polynomial function given the roots. When you know what the roots are, how do you get the polynomial? So a few things to think about before we begin with some practice problems. First, when we're writing the polynomial given the roots, the first thing that we want to do is to change the zeros or roots. Remember, zeros and roots are the same thing, to change them to factors. And when you do that, as we'll see in a few minutes, the parentheses are going to be put around them, and you're going to end up going backwards from root to factor. And once we get all of the factors, we're going to multiply them all together, which is kind of like distribution. Some of you will use a little bit of FOIL and some really just multiplying everything in each polynomial times the others. And then we'll check at the end to make sure that we've got the right degree number. That, if we end up with a third degree, but we have 4 roots, we've done something wrong. We should have a 4th degree. Remember, we've seen this in practice as we've been solving them, but anytime you have a square root, a radical root, you always end up with a pair, a positive one and a negative one. The same thing is true of imaginary roots. They always come in pairs as well. So here's our first example. We're going to find the polynomial with the given roots. So we're working backwards here. You've got to think about the difference between a root and a factor. See, these are roots or zeros. They're what you would plug into the function in order to solve it. We want to get the factors first. Now, anytime you have a root or a zero of 0, that means that you have a factor of x, because remember, when you're factoring, if you have x by itself, then using the zero product property, you would say that x equals 0. In order to use -4, we have to have x plus 4 as the factor, because if we set x plus 4 equal to 0, we would get -4. So you'll notice that as we're writing these in parentheses, it's going to be x plus or minus the root, but it's always the opposite of whatever the root is. So here we've got x times x plus 4, and then x squared times, x minus 2 times x minus 6. Now, when I'm multiplying these out, I usually work with 2 at a time. So I'll start with x times x to the 4th, where I'll distribute that x into the parentheses to give me x squared plus 4x. I will then look separately at the second 2 parentheses and FOIL them as well, which is x squared minus 6x minus 2x plus 12. Remember, it's first times first, outside times outside, inside times inside, and last times last. Another way to think of it is x times both terms in the second parentheses, and then -2 times both terms in the second parentheses. Let's clean this up. What does minus 6x minus 2x combine to give us? It gives us -8x. So I'm just going to change that right here to minus 8x. All right. Now we're going to multiply our first parentheses times our second parentheses. So we'll say x squared times x squared is x to the 4th. And I don't need parentheses here because I'm at the very end. So x squared times x squared is x to the 4th, because 2 plus 2 is 4. X squared times -8x is -8x to the 3rd. X squared times 12 is positive 12x squared. So we've multiplied x squared times all 3 terms, and now we do the same thing with 4x. 4x times x squared is 4x to the 3rd, because 1 plus 2 is 3. 4x times -8x is -32x squared, because x times x is x squared, right? And then 4x times 12 is positive 48x. Now what you'll notice here is we have some like terms, don't we? We have some x to the 3rds that could go together. We have some x squareds that can go together. And then we have a term at the front and a term at the end that don't have anyone to combine with. We want to put these in descending order based on the degree or the exponent. So we'll start with x to the 4th. So the negative 8x to the third plus 4x to the third is negative 4x to the third power. Taking care of both of those. And now I'm going to do 12x squared minus 32x squared. So when you have different signs, you subtract and keep. So it's going to keep the sign of the bigger one, 32. And 32 minus 12 is 20. X squared plus 48x. All right, so we have multiplied all of them together. The one thing that I want you to remember when you're doing this is that if we have 4 roots, we need to have a degree of 4 in our final answer. And since we do, we can put that big circle or box around it, and we know we've done it. Hopefully, we've done it right. In our second example, we have an irrational root, a square root that's part of our answer. Now, notice that this is both a positive and negative root 7. That means that it's going to be a root, 2 different roots. So we actually have 3 roots here. We have negative 3, positive root 7, and negative root 7. So when we write our factors, we'll have x, change it to plus 3. We'll have x, and this plus root 7 will change to minus root 7. And the minus root 7 will change to, or negative root 7 will change to plus root 7. These radical roots, or these square roots that are zeros, always come in pairs. So you'll never have a square root of 7 that's positive without the negative counterpart, or the negative one without the positive counterpart. It is recommended that when you are multiplying these things together, that you start with the ones that have the square roots, the radicals, or imaginary numbers first. If you don't, it gets really messy before it cleans itself up. If you do, it cleans itself up really nicely from the very beginning. So since I only have one x plus 3 at the front, I am just going to bring it down. And then I'm going to multiply these two together using FOIL. So x times x. Now what will happen every time here is when we do x times positive 7, or positive root 7, and then x times negative root 7, we get opposites. And what happens is they cancel each other out. So I'm not even going to write it here. By doing this first, x times x is x squared. The outside and inside cancel each other out. I don't have to write it down. And then I'll just multiply negative root 7 times positive root 7, which is negative root of 49, and the square root of 49 is 7. So what you'll notice is when you multiply a square root times the same number under a square root, you get that number. That was really fast, and they all kind of work out that way for the most part. That was pretty simple and fast if I had multiplied x plus 3 first into x minus root 7, gone left to right. It would have gotten really messy. I would have ended up with lots of radicals and all kinds of other stuff, and it would have been much more difficult here at the beginning. Eventually, it would work out to be right, but it just wouldn't have been as easy as getting x squared minus 7 here. Now I can distribute the x plus 3 into the second parentheses by multiplying x into x squared and negative 7, multiplying the 3 into x squared and negative 7, and then making sure I put things in the correct order and combine any like terms. Now with this problem, they're not in the right order, but I don't have any like terms to combine together, so I just want to put them in order from least to greatest. So we'll start with x to the third plus 3x squared minus 7x minus 21. That is the order that I wanted. That is my final answer. I have 3 roots here, 1, and then the positive and negative. I have a degree of 3 for my polynomial, so I probably did some things right there. Notice that when you have an imaginary root, you're going to have the opposite root as well. This is always true. And it actually makes this process a little bit easier to handle. So here I'm starting with the factor of my negative 1 is x plus 1. Now, fractions are you have to think about those. You have to remember that when you're solving, when you set 2x minus 1 equal to 0, I'll go ahead and write it here. When you're going the other way, you add the 1 first and then divide by 2 to get that fraction. So what's going to happen when we're going backwards is the denominator has to go in front of the x, and the numerator is going to be added or subtracted at the end. That's the easiest way to handle this. Otherwise, you're going to end up with a fraction in here, and that's not it's going to complicate things. So 2x minus 1 is the factor for 1/2. If it had been a negative 1/2, it just would have been 2x plus 1. But the top goes last, and the denominator goes in front of the x. We put x plus 3i and x minus 3i. So I can multiply x plus 1 times 2x minus 1 first. I just can't multiply something that's not an imaginary number into that imaginary factor, because that's where things get really messy. So I'll go ahead and multiply x plus 1 times 2x minus 1. And that gives me x times 2x, which is 2x squared, x times negative 1, 1 times 2x, and then 1 times negative 1. And remember that when we clean up, the outside and inside add together. So that's going to be negative 1x plus 2x, which is positive 1x, or plus x. I'm going to go ahead and clean that up right here. Okay. Now, when we multiply these together, we have to do this in the first step. We have to do them together. It's going to be kind of like the radical a second ago, where we multiply first times first. That was really easy. It's x squared. When we do the outside and inside, that negative 3ix plus 3ix are going to cancel each other out, so we don't actually have to write them down. We just go ahead and multiply last times last, which is negative 9i squared. What do you remember about I squared from earlier this year? Well, hopefully you remember that I squared is the same thing as negative 1. So whenever you see an I squared, you can go ahead and change it. So here we have negative 9 times I squared, which is negative 9 times negative 1. And a negative times a negative is a positive. So we have the ability to simplify this, and now there's no more imaginary part. We can almost just say, it's gone now. Doesn't exist anymore. We fixed it. Now we're going to multiply every term in the first parentheses times every term in the second parentheses to finish out this problem to give us, let's see, 2x to the fourth plus 18x squared. That's 2x squared times everything in the second parentheses. Now we move on to x times both. That gives us plus x to the third plus 9x. And now negative 1 times both terms in the second parentheses gives us minus x squared minus 9. At this point, we do have to clean up some things. We have some like terms here that we can put together, and we have things that are not in the correct order. So let's see if we can get them in the correct order. We have 2x to the fourth plus x to the third. We can put the x squareds together to give us plus 17x squared. So I've taken care of, sometimes I like to mark them off, this one, this one, this one, and this one. I still have left over 9x, it's positive 9x minus 9. And that is that huge polynomial that these roots would give us. Now remember, if you notice that I make a mistake, if you're the first one to say, hey, Mr. Ezra, I was watching the video and I worked it out and I didn't get the same thing, you might can get extra points, bonus points. So let me know. Be the first person to tell me that there's a mistake, but hopefully I haven't made any. Okay, let's look at this one. We have 1, 4, and root 2. What has to be true if root 2 is a 0? If the square root of 2 is a 0? Well, they always come in pairs, right? So if positive root 2 is one of the roots or one of the zeros, that means that the negative version of it is also 1. So we have to think about that before we start multiplying. There's not 3 roots here. There's actually an implied fourth one. It's just not listed. And you have to be aware of that, and you have to add it in before you start multiplying. So we've got x minus 1 times x minus 4 times x minus root 2 times x plus 2, root 2. So just a quick reminder that when we multiply this, we have to multiply the squares, the square roots first. That has to be part of our first step. And the other two we can go ahead and multiply together as well, but those have to be together to make life easy for us. I'm going to go ahead and fast forward through this, and I'll see you at the end of the problem. All right, so hopefully I've multiplied this correctly. I started by multiplying the two non-roots together and the two roots together. And those, I love how quickly these multiply, where you say x times x is x squared, and negative root 2 times positive root 2 is 2. And we've multiplied this together. It took a little bit longer to do the trinomial times the binomial, but hopefully I've done it correctly, and I ended up with a polynomial that is fourth degree, and I started with 4 roots, which means that I think I've done it correctly. Let me know if I made a mistake anywhere. Another example, we have -1 as a root, -1 as a root, and 2i as a root. If 2i is a root, what must be true? What are we missing? Well, if 2i is a root, then -2i is also a root. They always come in pairs. Also notice that -1 and -1, that's called a double root. So we have a double root here, which isn't a big deal. It just means that we're going to have two factors that are the same. We'll have x plus 1 times x plus 1. And then x minus 2i times x plus 2i. Now, as we're multiplying this out, I'm going to fast forward again, multiplying the x plus 1's together, and then I'll multiply the imaginary terms together on the first step so that things kind of work out a little bit more nicely. All right, so I multiplied x minus 2i times x plus 2i, and at first I got x squared minus 4i squared, but that I squared changed the negative to a positive because it's -1. I multiplied x plus 1 times x plus 1 and got this trinomial. Then I multiplied the trinomial times the binomial and got all these terms. A few of them went together, and I put them in descending order to get my final answer. What we find with these types of problems is they're not extremely difficult, but you do have to be really careful. As someone who is prone to make mistakes myself, if you're not careful when you're multiplying, you might end up multiplying something incorrectly. And one check that you can check is that the degree at the end works, that when you get to the final answer, the degree matches. Another thing that you can do is you have a graphing calculator. So you can plug the function that you get at the end, the polynomial that you get at the end, into your calculator and graph it. And it should go through the x-axis at the zeros that you know are rational good zeros. And that's a good check. It's a way to check to make sure that you've got it right. Thank you so much for listening to my video, and I'll see you in class.